Hello and welcome to the 6-4 notes. This is a section about rectangles, and a rectangle is a special type of parallelogram. So I'm going to first zoom in here. We've got a few things we needed to talk about, but a rectangle, the first thing I'm going to say is that it's a special parallelogram. Okay, it's the first of many. Parallelogram. Okay. And some of the properties that we know about rectangles is that opposite sides, so opposite sides are parallel and congruent, okay, just like in parallelograms, okay. We know that all angles are congruent, okay. And then we know that, so if all angles are congruent, then they're all 90 degrees. So all 90 degrees. Okay, and then the most important thing, the thing that we know about a rectangle is that the diagonals are congruent. Diagonals are congruent. Okay, so we can tell if something is a rectangle based off of these properties. So let's go ahead and draw a picture of a rectangle. So I'm going to come in here and draw a straight line like that, and like that, like that, and like that. Okay, and I'm going to call this, rectangle A, B, C, and D. Okay, and the one thing that I know is that the opposite sides, the first thing I know is the opposite sides are congruent. So I'm going to say that AB is congruent to DC. Okay, and I'm actually going to write that over here. I'm going to write that AB is congruent to DC. Okay, and then we know that AD is congruent to BC. Okay. So I'm going to write that over here. I'm going to say that AD is congruent to BC, okay? And then we know that the diagonals are congruent as well. So I'm going to come in here, and I'm actually going to draw in the diagonals in red, okay? And so what we then know is we know that AC is congruent to BD, okay? And so if they're also congruent, so the diagonals are congruent, we should also note in here the diagonals are congruent and they bisect each other. So they bisect each other as well. I forgot to put that, bisect each other. Okay, so we can come in here and label this like that. We can say that all of these segments are congruent then, okay? And then finally, the last thing that we can say is that all the angles form 90 degrees, okay? So angle A, so I'm going to say this, angle A is congruent to angle B, which is congruent to angle C, which is congruent to angle D, okay? And they're all 90 degrees, so all right angles. Okay, so those are the properties of a rectangle. You should be fairly familiar with what a rectangle is, but let's go ahead and apply these ideas. And I'm going to do the same thing here. I'm going to come in here and label this picture. Okay, we know this is a rectangle, so I'm going to come in here and automatically say that my opposite sides are congruent. Okay. That my diagonals are congruent and they bisect each other. So all of these segments in here are congruent. And then we know that all of our angles are right angles. Okay, so that's going to help us answer these questions. So let's go ahead. It says that if AC, so if segment AC is 2x plus 3, and dB is 4x minus 1, then we want to find the length of dB. So if we know that dB is this algebraic expression, if we can set up an equation and solve for x, then we can go ahead and figure that out. So let's go ahead. We know that AC and DB are the diagonals. We know that the diagonals are congruent. So I'm going to go ahead and set up an equation and just set 2x plus 13 equal to 4x minus 1. Okay, I'm going to subtract 2x from both sides, and that's going to give me 13 is equal to 2x minus 1. I'm going to add 1 to both sides, and so that gives us 14 is equal to 2x. Okay, so 14 equals 2x. I'm going to divide by 2 and divide by 2. So then we know that x is equal to 7. Okay, so once we found x, we just need to find what dB is. Okay, so dB, all right, dB is 4x minus 1. Okay, I'm going to plug 7 into that. So 4 times 7 minus 1. And so that's going to give me 28 minus 1, which gives me 27. So dB has a length of 27, okay? Let me take a look here. AE and EC, I'm going to let you guys do number 2 on your own, okay? And so let me write that. I want you guys to do that on your own. So on your own, okay? And I'm actually going to have you do number 4 on your own. Okay, so those are the problems you need to do on your own. I am going to do number 3 with you. Now, I want to kind of zoom in here and talk about this for a second. It says, if angle BDC is 7x plus 1, so we're given BDC, and then we're asked questions about ADB, we need to find the measure of angle BDC. Now, ADB and BDC, these are complementary angles. They add up to 90 degrees. So I'm going to set up an equation and say that 7x plus 1 plus 9x minus 7, if I add those angles together, it will give me 90 degrees. Okay, and now I just need to solve for x. Okay, and so I'm going to combine my like terms. 7x and 9x gives me 16x. Positive 1 and negative 7 give me negative 6 is equal to 90. So then I'm going to go ahead and add 6 to both sides. So we end up getting that 16x is equal to 96. So if I divide everything by 16 and 16, I get that x is equal to 6. Okay. So once x is equal to 6, it asks me to find angle BDC. I'm just going to plug that into here. So I know that angle BDC is equal to 7 times x, but x is equal to 6. So I'm going to plug in 6 into that and then add 1. Okay. And so that's going to give me 42 plus 1, so that's 43 degrees. So angle BDC is 43 degrees. Okay, so go ahead and do number 2 and number 4 on your own. Both of those problems are similar to the ones we just did. So apply those ideas, and let's go ahead and move on. Okay, so let's take a look here. I'm going to do 5 and 6. Number 7, I want you to do on your own. Okay. All right, and so that's what I'll be checking in class. So number 5. It wants to know, it says graph each quadrilateral with the given vertices, determine whether the figure is a rectangle, and we need to do that using the slope formula, okay? So let's go ahead and just plot the points and see what we have here. I'm going to go ahead and plot the point -3, -2, that's point P. I'm going to plot point Q, that's -4, +2, and then I'm going to do 2, 4. That's R, and then S is 3, 0. Okay, so I'm going to call this P, Q, R, and S. Okay, and I'm going to go ahead and zoom in on this and connect my dots. All right. Okay. Okay. All right, so what we want to figure out is is this a rectangle? Okay, and so the one thing that I want to do here is I want to determine the slopes of these lines. I want to figure out, are these perpendicular? Okay, and so, we know that QR, let's just take a look here. Let's just draw our little right triangle in here to see what we've got. We go up by 2, and we go over by 1, 2, 3, 4, 5, 6. Okay, same thing over here. We go over 6, we go up 2. And so we know that the slope of QR, so I'm going to write that. So I know that the slope of QR, all right, is equal to 2 over 6, which is 1/3, okay, and it's positive. I also know that the slope of PS is the same thing. We go up 2 and over 6, so we get 1/3, okay? So then we want to figure out, well, what's going on with QP and RS? And I know that these are the same, all right, so I know that those are parallel, but I'm trying to figure out, are they perpendicular? So I'm going to come over here to QP and draw that triangle, and we're going to go down and over. We're going to go up and over here. So this is a 4 by 1 and a 4 by 1. Okay, so if I wanted to figure out what QP was, the slope of QP, so slope of QP, all right, that's going to give me negative 4 over 1, so negative 4 over 1. Okay, and then the slope of RS, okay, is the same thing, negative 4 over 1. So we know that we have a parallelogram. We know that opposite sides are congruent, but these are not opposite reciprocals of each other, okay? So I'm going to write that these are not opposite reciprocals, okay? So the angles, all right, the angles formed are not 90 degrees, okay? If they were 90 degrees, then these would be opposite reciprocal slopes, okay? So this is not a rectangle, so not a rectangle, okay? All right, let's go ahead and take a look at number 6, and then we'll stop with that. So let's go ahead and plot our points here. Let's plot point J. That's negative 6, 3, so 1, 2, 3, 4, 5, 6, up 1, 2, 3, plot a point. Okay, K is 0, 6, so 1, 2, 3, 4, 5, 6. Okay, L is 2, 2. And then M is negative 4, negative 1, so 1, 2, 3, 4, down 1. Okay, so this is point J. This is point K. L is right here, and then this is point M. Okay, so what I'm going to do is I'm going to zoom in here and connect my dots. Okay. All right. And so what I want to do is I want to figure out, we have to use the distance formula to determine whether this is a rectangle or not. So what I'm going to do is I'm going to calculate the distance between MK. That's what I want to find. So I want to find the distance of MK. Okay. And so let's go ahead and I'm going to draw that line here for MK. All right. And so in order to get the distance, I'm going to create a right triangle between those 2 points. And so I'm going to make a line going that way and a line going up. And this is a 1, 2, 3, 4. And this is a 1, 2, 3, 4, 5, 6, 7. This is a 4 by 7 triangle. So I'm going to set up my distance formula here. And MK is going to be equal to the square root of 4 squared plus 7 squared. Okay, so then MK is equal to the square root of 16 plus 49. All right. Which is going to give me a value of the square root of 65. Okay, that's what MK is. All right. So now let's do the same thing, but let's find the distance of the other diagonal, distance of JL. Okay. And so JL, let's go ahead and do that one. And this one is if we draw the right triangle, if we connect those 2 points, okay, and then draw a right triangle here, we get that this is a 1 by, 1, 2, 3, 4, 5, 6, 7, 8. Okay. Now, those aren't the same triangles, but we want to see if those are congruent. Okay, so let's go ahead and use that. Let's use the distance formula, or Pythagorean theorem. And so I get the square root of 1 squared plus 8 squared. So then I get this. I get JL is equal to the square root of 1 plus 64. Oh, look at that. Okay, so we find out that JL is equal to the square root of 65. Okay, and that's the same thing. Okay, so this is the same. Okay, and so we can say this, that the conclusion that we can draw is that quadrilateral JKLM is a rectangle because the diagonals are congruent. Okay? So that's what we want to check. So go ahead and do number 7 on your own. That's the same type of problem as number 6. So I hope you enjoyed this video. Rectangles are pretty cool. So, well, I think everything in geometry is cool. So, just take my word for it and have fun with it. So I hope you enjoyed it. See you later. Bye.